So here is the Degree-Radian Conversion rules. If you want to go, or you need to go from degree to radians, all you have to do is multiply whatever you have for degrees by pi over 180 degrees. If you need to go from radians to degrees, you're going to multiply what you have for radians by 180 degrees over pi. So how would this work? So let's do some example. Alright, so say we start off with our first example, 90 degrees. And you want to go into radians. So what we're going to do is we're going to go 90 degrees times pi over 180 degrees. So, just like when you're multiplying a whole number to a fraction, all you gotta do is just have the whole number multiplied to the numerator. That's all you gotta do to make it simple. So, what's it gonna look like? On the numerator, it's gonna be 90 degrees pi over 180 degrees. Now, you can simplify the numbers. So, 90 over 180. So if I were to simplify to make it look easier, I can remove the 0 because they're both divisible by 10. So 9 degrees over pi over 18 degrees. And then to focus again on the numbers, 9 degrees over 18 degrees is basically 1/2. So 1/2 would be 1 pi over half, and basically 1 pi over 2 is the same thing as pi over 2. You can write the 1 or you don't have to write the 1. But that's basically what you would do when converting from degrees to radians. So 90 degrees is pi over 2. Now, you didn't have to do the whole steps, but I was just showing step by step how to go from 90 degrees to pi over 2. Now in our second example, say you're given 36 degrees and ask you to change to radians. So just like before, multiply 36 degrees by pi over 180 degrees. Now again, when you're multiplying a whole number to a fraction, all you gotta do is multiply the whole number just to the numerator. So it's gonna be 36 degrees pi over 180 degrees. Now, say I'm rusty with my common factors between 36 and 180. So what I would do is I would do small steps. I know that 36 is even and 180 is even, so I'm going to divide the numerator and the denominator by 2. So 36 divided by 2 will be 18, and then with the pi over, and then 180 degrees divided by 2, and that's 90. Alright, so that looks much more simpler. So now think about what's common between 18 and 90. Well, here's something I noticed. This 90 has a 9 in it, so 90 for sure can be divided by 9. How about the number in the numerator, 18? Can that be divided by 9? Sure it can. So what I'm going to do is I'm going to divide the numerator and the denominator by 9. So you can also divide by 2. It's just you're going to do maybe one or more 2 steps what I'm doing. So 18 divided by 9, that's going to be 2 with the pi on the top over 90 divided by 9 would be 10. Well, I notice I can still simplify further because 2 and 10 are even numbers, and if I were to divide that by 2 again, So we'll be left with 1 pi in the numerator and 5 on the bottom, which will simplify to pi over 5. Now, in the description about radians measure, sometimes it's okay to leave it as pi over 5. Sometimes they say pi over 5 radians or rad. Now, whichever you write or leave it as doesn't matter to me, because if I see that you're using pi, that means that you're using radians, which is fine. We're not really picky about you writing rad or radians, but in the event you have a question, in the event you have a professor telling you to write it specifically, so my sufficient answer would be pi over 5, but sometimes they might have you write pi over 5 rad or radians. In example 3, we have negative 75 degrees and we want to convert into radians. So it's going to be the same process even though this is a negative degree. So I'm going to multiply negative 75 degrees by pi over 180 degrees. And again, the whole number times the numerator, that's all you got to do. So negative 75 degrees pi over 180 degrees. Now, what is in common between 75 and 180? Well, since 180 ends with a 0, that means that you can divide it by 5. So what I'm going to do is I'm going to divide top and bottom by 5. So negative 75 divided by 5, that's going to be negative 15 pi, and then 180 degrees divided by 5. So it's going to be 3. 3 goes in 5, 15. I'm left with 30, so 6. Alright. So 180 degrees divided by 5 would be 36. Now, again, since I'm dividing with degrees, I don't have to write the degree symbol. Now, can I simplify this even further? What's in common between 15 and 36? Well, let's see. 36, I would look at that one because that's a higher number. 36 has a lot of factors, but let's start with small numbers. Besides 2, because 2 cannot go in 15, what about 3? 3 can definitely go into 36, and 3 can definitely go in 15. So we're going to divide top and bottom, numerator and denominator, by 3. So negative 15 divided by 3 would be negative 5 pi over 36 divided by 3, that's going to be 12. And checking, there's nothing in common between negative 5 and 12, so basically it's going to be negative of 5 pi over 12. So when you have a negative in the numerator, we're just going to put the negative in front. And again, this answer is sufficient for me, but sometimes you might have to require to write negative 5 pi over 12 rad. Doesn't matter to me, but in case when you see like a question or a answer format, that's what it's going to be again. So negative 5 pi over 12 or negative 5 pi over 12 rad. Here in example 4, we have now pi over 6, and we need to convert into degrees. So to convert to degrees, multiply radians by 180 degrees over pi. So pi over 6, and I'm putting in parentheses because it's a fraction. We're going to multiply fractions. 180 degrees over pi. So when you multiply a fraction, numerator times numerator, denominator times denominator. So it's going to be 180 degrees pi over 6 pi. And then looking at this, pi divided by pi, that's going to become 1. So what we're going to have left is just 180 degrees divided by 6. Now, if I were to compare with 18, because we have 180 degrees, with 6, that's divisible by 6. So I could do 180 degrees divided by 6. So if I were just to focus, 18 divided by 6 is 3. But now 180 degrees divided by 6, that's going to be 30 degrees. So 180 degrees divided by 6 is just simply 30 degrees. And this is our final answer. Alright, our last example, we have negative 3 pi over 2, and we need to convert to degrees. So same process in the last example. So negative 3 pi over 2 times 180 degrees over pi. So again, numerator times numerator and denominator times denominator. Now I'm going to carry the negative with the numerator, so it's going to be now 3 times 180 degrees. That's going to be a big number. So what I'm going to do is I'm just going to write it as a separate factor. So negative 3 parenthesis times 180 degrees parenthesis with the pi. Then it's just going to be 2 pi on the bottom. Now again, you can do negative 3 times 180 and then divide by 2. But for me, personally, when I'm working with 180, I don't want to get a big number and it's going to be too much work or get confused and then get lost. So what I would do is, let's see, with the 2 right here, well first, let's work with pi. Since we have a pi in the numerator and a pi on the denominator, I'm just going to rewrite it with just the numbers. So negative 3 times 180 degrees over 2. Now, looking at that, I can't find anything common between negative 3 and 2, but I can find something common between 180 degrees and 2. So I can do 180 degrees divided by 2. So if I were to simplify top and bottom by 2, I'm going to be left with negative 3. And then 180 degrees divided by 2 would be 90 degrees. And then 2 divided by 2 is just 1. And now it seems easier. I could definitely do negative 3 times 90 degrees. So that's going to be negative 270 degrees over 1. And of course, you can't just leave it like that. If it's divided by 1, you're just going to write it as negative 270 degrees. So that's going to be our final answer for this example. Now to review, we were converting negative 3 pi over 2 into degrees, and when I multiply, I carry the negative with the numerator, so the negative 3, and then I wrote it as negative 3 times 180 degrees. I didn't want to have a big number since I'm not good simplifying with fractions. So we have negative 3 times 180 degrees from here times pi. So the pi came from over here. And then 2 times pi is 2 pi on the denominator. Next step is I simplify by dividing the pi's. So I'm left with negative 3 times 180 degrees over 2. So looking at it, I couldn't find anything common between negative 3 and 2, but there was something common between 180 degrees and 2 because they're both even. So I divide top and bottom by 2. So what I have now is negative 3 times 90 degrees over 1, and then I just multiply the numerator, so negative 3 times 90 degrees is negative 270 degrees over 1. Basically, negative 270 degrees divided by 1 is just simply negative 270 degrees.